Welcome back. In one of the earlier classes, we talked about the resolution which is needed for virtual reality from the anatomical point of view. We looked at the photoreceptors, rods and cones. From there, we had derived what is the resolution possible. In the later classes, we talked about psychophysics, the measurement of perception. The resolution is therefore, is it going to be limited by the perception? Psychophysics, as you all know, it is just not the physiology or anatomy, but actually the perception. The relation between the perception and the anatomy or physiology. So, the earlier resolution which is dictated by the anatomy and resolution, how is it going to be modified by the psychophysics is what we are going to see, and we are going to come up with a further limiting resolution. For this, we will look at the contrast sensitivity function, which we already discussed in one of the previous classes. The CSF function talks about for different spatial frequency how the threshold is actually increasing. Actually, this y axis is the sensitivity. Threshold is which we have seen is the inverse of the sensitivity. So, the higher sensitivity where at this point we need the lowest threshold. As the sensitivity decreases, we need higher and higher threshold. For example, here we might need at this particular frequency we might need more threshold. So, the implication of this CSF, which we have already seen in the earlier class, that if a picture which has higher frequency details, then this diagram tells that we need more threshold in order to be seen. That is the implication of this graph. Similarly, very low frequency also needs higher threshold. The least threshold is necessary only for the medium frequencies. That is the implication of this, right. So, how we can use this sensitivity function in order to come up with a limiting resolution is what our topic today. For this, let us again get into the definition of what is the resolution, what is the contrast, and then see whether we can connect these two things. Okay. The spatial frequency, let us say an image, spatially varying image such as this one, where there is a black and white. Let us say we are giving this as input to our system. The system, let us say it is a generic one. Let us say the system outputs an image which is transformed in some way. In this case is this is giving an image like this. The input image where binary, the black and white image is converted into a gray image. If you look at the black and white, the below picture, the black and white image which has this change in the contrast, this is the black, this is the white, the square grating kind of things, right. And when this is given to the system, this is transforming the image into a sinusoidal gray level image. Okay. So, here the contrast is 100% because there is only black and white, and the contrast definition, and if you look at it you can say this is a I max minus I minimum divided by I max plus I minimum. this in terms of the percentage contrast. This is one definition of contrast, right. This is one definition of contrast. So, in this case this is going to be 100%, whereas here this contrast has reduced over here. Let us say this is a 90%. Okay. So, here there are two concepts, the concept of resolution also we can look at it, the concept of contrast also we can look at it. There is a connection between the concept of resolution and contrast. Resolution is the closest two lines that can be separated. Okay. Suppose if we give this image as an input to the system, the output can it be resolved into two separate lines, or what is the highest frequency which can be resolved into two different lines in the output system, right. That is a resolution. You can see that this resolution from the output image which we are determining, that is limited by this contrast. Again, to look into a little more detail, let us look at the how this contrast is limiting the resolution. Suppose if we change the contrast gradually from left to right, where we have only black and white, but slowly we are reducing this contrast, or yes, reducing the contrast. Here the contrast is reducing. Contrast. This is a black, this is a white, and initially it is the completely black and white, and this is a white, and the black is reduced, and finally we reach some. So, again using the definition what we have written, I max minus I minimum divided by I max plus I minimum will tell you what is the contrast over here. Okay. This contrast is what limiting the resolution. For example, again we have our system over here. Okay. If we increase the frequency, let us say in this case we are increasing the frequency double, then our system we are talking about, system is no more separating the lines in the output image. You can see that the output image has lesser contrast. Let us say in this case it is 20% of the contrast. So, now this resolution we will define in terms of the modulation. So, if we have a system, input frequency and output spatial input frequency, output frequency, output modulated image, output modulated image. Okay. So, we will see how this contrast is transferred. Okay. So, if we draw a graph, let us say in the x axis we have this frequency, in the y axis we have this threshold function, MTF factor, let us say modulation, transfer factor. So, a system transferring the modulation of the given input to the output, if it is completely transferring, then it is, let us say this is number 1, if it is reducing, then it may be now lesser than 1. So, modulation transfer function factor, let us draw it in the, let us plot it in the y axis. For various frequencies, this may be 1, but all of a sudden it may be reducing. This function is called the modulation transfer function or MTF. This MTF is a system property, and this system property can be measured using various approaches. Assuming all this is a linear system, MTF of different components can be convolved with many other MTF. For example, in our system we have the electronics. In our virtual reality systems we have electronics, we have a optical system, and then we have the software system. Each one may have a MTF, MTF 1, MTF 2, MTF 3. So, the system MTF can be determined as convolution of MTF 1, MTF 2, MTF of 3 kind of. This is the system MTF, right. So, this system MTF, let us say we have somehow found out from some test for our virtual reality headset. Now, as long as MTF is concerned, there is no perception involved in it. The perception will come into picture when there is a the contrast sensitivity is involved. The contrast sensitivity involved, the CSF function, if you remember, that can be now brought in together here, but CSF is a sensitivity is measured here, because the y axis is a modulation transfer function. It can be the inverse of CSF needs to be plotted in this graph. So, instead of CSF we will say contrast threshold function. So, we remember our threshold is equal to 1 over the sensitivity. Therefore, the same function can be plotted something like this. This is the CTF, this is a contrast threshold function. Okay. So, this threshold function tells you what is the threshold necessary as we increase the frequency. So, as we seen in the CSF, there is a maximum frequency, or there is a frequency at which it needs the least resolution, least threshold. At the lower frequency it has the it needs higher threshold. Similarly, as we increase the frequency it needs a higher threshold as well. Now, the frequency at which this MTF and then CTF joins could be a valuable information. This could be called as the limiting resolution. This limiting resolution is dictated by this perceptual graph. This is where the psychophysics come into picture. So, the resolution earlier it was dictated by the anatomy and physiology. This MTF is dictated by the system properties, the outside the system properties. Now, this resolution CSF which is a psychophysical curve. Together we can put them together to find out what is the limiting resolution. Now let us look at the CSF curve in one of these CSF curves. So the CSF curve is mentioned as it's about 40 cycles per second is where the limiting resolution happens. This is one, let us say. This is the modulation transfer factor. This is a threshold. Okay. So this graph tells that at about 40 cycles per second there is the limiting resolution happens. This is the arc. So if you have field of view 120 degree, so this is 40 cycles per arc, this is the frequency per arc, we can say per arc per degree. Okay. So number of pixels needed for 120 degree is going to be 120 into 40, which is going to be 4800 pixels. As of now we have about 1200 pixels, that is a, let us say state of the art. So in order to reach this 4800 pixels we might need 10 years we will reach this limiting resolution, assuming the Moore's law is constant and that is valid. So every 5 years this pixels is going to be doubling, therefore after 5 years this is going to be 2400 pixels, and after 10 years we will reach the 4800 pixels. But that is assuming 120 degree field of view, but our industries are going to consider much more field of view as we are going to see in the later classes. So for 200 degree, let us say this is going to take 200 into 40, it is about 8000 pixels. To reach this 8000 pixels we might need probably 15 years, let us say, again assuming the Moore's law is constant and that is valid. So we are right now at 1200 and so it will get doubled in 5 years, that is going to be 2400, that is again going to be double 2 times, that is going to be 4800, that is in 10 years, and that is again is going to be double 9600, that is about 15 years it will take. All these things again we are going to assume that this MTF of different components of the system, MTF1, MTF2, MTF3, all these things are assuming those things as constant. Maybe each of this MTF will be improving, therefore the requirement of this 40 may be reducing in the future. So this might become now 30 or better. If that is the case, the number of resolutions required, this all will be lesser reduced. So I hope you see the point of how our psychophysics can be used to find out what is the limiting resolution that can be useful in design of the better imaging systems or better visual systems which is used in virtual reality. We will stop here. Thank you.